All right, welcome everyone. This is a joint session between me and Hari. We're going to be sharing our experience on how we've been working with several organizations to unify their OpenAPI and async API specifications. Specifically, like how do we share the schema and the examples? How do we design so that there is maximum reuse between these? So we will start off with me just setting the context, and then we will hand it over to Hari for an actual live demo. Hopefully everything goes fine. So let's jump straight in. I wanted to start with a real world application that everyone can relate to. We've taken a very simplistic scenario over here. So we have a order application which is going to place an order onto the order BFF. The order BFF will receive the request, it will do the validations, and then save the data in a database. It will also send out this message on the new orders topic so that the processing of the order can happen asynchronously. And then once it's posted the message, it's going to get back with a 202 response to the order app, and the order ID will be sent back so that the order app can use the order ID in future to track the progress on the order itself. Now we switch and look at what's happening at the new order, right? So we have a order service which might have subscribed to messages on the new order topic, and then as soon as it receives the message, it will actually start processing the order itself. And then at regular intervals, it might need to update what's happening with the order and might put messages on relevant topics for respective applications to pick up and do their pieces, right? And the order BFF, of course, would also subscribe to these topics so that it can receive updates and update the database so that in future, whenever there are requests, the order BFF has the latest state of the order itself. So now let's say at some point the user goes back to the app and wants to see what's the status of their order. So they would, there would be a get order 123, for example, request. And the order BFF would retrieve the details, the latest details from the database, and then serve it back to the app. I hope this is a very simple scenario that all of you can relate to, where we start off with REST or synchronous API calls, and then we hand it off to a asynchronous part, right? Now, typically for the synchronous parts, you would be familiar with OpenAPI specification. So we would try and capture all these interactions and in form of an OpenAPI specification. Similarly, on the async side, you would capture that on the async API specification, where you might be using Kafka, you might be using Google PubSub, or you might be using MQTT, any one of the several protocols that are supported by async API. Now, what is so interesting about this, right? The interesting piece with this is often people, often these synchronous and asynchronous worlds don't exist in as separate islands. They're always kind of interacting with each other and intermingling with each other. And when you have two separate specifications which are capturing these, the challenge is to ensure that we don't have any kind of drift between them. Also, we want to make sure that as things evolve, because applications evolve, specifications evolve, we want to make sure that they always stay in sync, right? So let's quickly jump in and look at the OpenAPI specification for the order service itself. So here you will see that we have, paths, slash order with a post, what we saw earlier. And then what is interesting is the schema section, under the components, where we have two entities, a new order and an order itself. Now, the new order is essentially whenever you receive a order request, and then whenever you get a request for getting the order itself, then you respond back with an order. And what you will see here is a little bit of reuse, right, which is a good practice going on, where the order itself is referring to the new order, so you don't want to duplicate that information again, and you're referring to the new order by using the all of, and then you're adding some additional properties. So that's a good practice, and that's good to see. Now, what do we reckon we will see on the async API specification? Because we would need to have a very similar schema. Of course, here you would see that we have channels, not paths, because we're talking about topics and operations on them. But you would still see that we have same component section, and here again we have the similar new orders and order, and the one problem that we see is these two things are kind of duplicated between the OpenAPI specification and the async API specification. We typically refer to this as a wet pattern, which is write everything twice pattern. And this leads to a slippery slope, right? Whenever something's wet, it leads to a slippery slope, and you would see that as the APIs evolve, there is a high probability of a drift between them going out of sync, and that causing a lot of confusion, right? And we don't want that to happen. So how do we design these specifications to avoid the duplication related problems, right? So what you will see here is we've slightly refactored both of the specifications, and we have pulled out the common sections into a common schema. And so whatever was there in the component section, which was duplicated, is now pulled out into its own schema, in its own JSON schema. And we see that here we are refing from the OpenAPI, we are refing out to the common schema. Similarly, from the async as well, we basically are refing out to this common piece. Now, by doing this simple extraction, what we have ensured is that we are adhering to the dry principle, and we are not letting duplication get in the way. And here is, of course, an example of schema duplication. But what do you think, Hari? Are there other things that also could be duplication related issues that we can avoid?
Certainly, I think there could be examples, which is a major part of API specifications. Maybe we could reuse that as well.
That's a great point, right? So it's not just the schema section, but there are examples. There are probably more things. So let's do one thing, right? Let's look at the OpenAPI specification and async API specification side by side, and let's see what does each of them compose, and out of these, what are things that we could actually reuse, right? So both of them have an information section. Both of them have the server and security section. These might be more specific to the protocols and the specification itself. So maybe not so much of a reuse over there. On the OpenAPI side, you would have paths and the summary and description. On the async API, those would then map to channels. And again, these are kind of different, so you probably might not reuse much over there. On the OpenAPI side, you would be familiar with operations like get, put, post, which is equivalent to, on the OpenAPI side, on the async API side, you would have actions like send and receive. Again, these are kind of specific to the protocols and the specification itself. Then you have request and response, right, which would effectively map to the headers and the payload. And this is interesting because I believe this is stuff that certainly could be things that you might want to reuse, right? But the good news is these are obviously not generally not recommended to have them all inline. They would essentially be refed out to components, and so those are the pieces that technically we would be able to leverage and reuse, right? There are tags, there could be external docs between them. So those are all, again, things that probably we don't really care so much about reuse. But this component section down here, right, like this is I think the most interesting piece is that you would have schemas which are like the request response being mapped out. So the schemas are, again, like both of them have OpenAPI and async API. Both of them have the concept of schemas. Both of them refer to JSON schema or other kinds of schemas, and then that is something that you can certainly reuse. There are examples, Hari brought that up. There could be parameters, again, those could be reused. So again, what you're seeing is that there are like this whole component section, and within those component sections there are several things that effectively can be reused between OpenAPI and async API specifications, ensuring that we don't end up duplicating things, right? So I think that's kind of brings us to the topic of how do we then think about designing this in a way that by design we are not ending up with this duplication, and we have the full synergy between the open API and async API. So this is where I think I would want to hand it over to Hari to jump in and kind of give us a actual demo of you know how we can design this, right? So over to you, Hari, for a demo.
Yeah, thanks, Naresh. So technically, we have covered the topic that we wanted to finish, right? Which is to say schema reuse. But does life end there? Probably not. Life of API begins when you actually think about what needs to be done further down the lane. So with that, let me quickly jump into the various stages in the life cycle of an API. We obviously start with a discovery phase. We're trying to understand who we are catering to, what are the needs of those people, and then basis that we are setting aside the acceptance criteria for what this API is supposed to do and what's the success of this API itself. What would it look like in terms of it being useful to people, and then going through a stage of adoption and whatnot. So once you have the discovery, then comes the primary phase of design, which is the responsibility of the architect who needs to put together the API, keeping in mind several aspects, right? Like there's a developer experience aspect, there's a security aspect, there's a domain and regulatory body related aspects which you have to think about. But even if you just take developer experience as one of the pieces that you want to talk through, there's so many pieces you have to think about. And then eventually it goes into implementation. And then in implementation, I'm talking about not just the writing of code to achieve what the API spec is set forth. It also means like deploying it and getting it into the hands of users so that it's available and ready to use. And post implementation is the evolution phase. Obviously, if we all hope to reach there, right? Which is the API is well received by the users and they ask for more, and then we have to evolve the capabilities to move forward. And that's the simplified four stages. There could be more, we could split it up, but for practical purposes, we could just remain with these four. Now, the key two phases that we have to work with here is the design and implementation phase, because as an architect, as engineers, as developers building this API, going from design to implementation, getting it into the hands of people, that's the time to market we have to be conscious about. And what does this entail? Let's deal with that. So the design phase, like I said, there are many pieces to deal with here from various points of view. But even if we just took developer experience as one of the pieces which we want to understand and work with, first would be standardization. Again, there are beautiful tools like Spectral and Vacuum, which can help you achieve a lot of this standardization, right? So, for example, let me flash this beautiful API design right here. As you, some of you might have already winced at the look of the lack of consistency. We have underscore snake case, we have Pascal case, we have camel case all over the place. There could be more, right? Pluralization of nouns versus non-pluralization. So the API design has to follow a certain basic standard in terms of predictability for anyone, be it within the organization or across multiple organizations. It's important to portray a sense of consistency, which is why standardization is important. And tools like Spectral and Vacuum play an important role in helping automate the standardization. Then comes the dry, not wet. Obviously, like Naresh mentioned, it's just a slippery slope when it's when we write everything twice. So we want to take the dry approach and not repeat ourselves. Examples are super important. They form an extremely educative piece of the API specification. More than the API specification itself, it's the examples that the users look at. And this is if the examples are out of whack, then that's a problem. We need to make sure that they are in sync, and that's where Specmatic can definitely help validate the examples against the API spec. And consistency. Let's for a moment look at this example that I pulled out from a real API specification. And the beauty of it is it's a UUID string, and almost everything is contradictory about it. So you have the format which is UUID, The example is not a UUID format, obviously, right? There is no hyphenation or anything for that matter. And then the regular expression pattern is again contradicting that. It doesn't have the 4 or 5 sections that a UUID is supposed to have, only has 3 sections, which is hyphenated. Now, from an API consumer point of view, this can be extremely difficult to follow because of all the contradictions that are happening here. So, consistency in your API specification is super important, and that's where validation is necessary again. And specificity, which is even like, slightly on the same note, right? Earlier we were having 3 different pieces which are all not agreeing with each other, but someone could define an API specification like such. Simply say there's an email field and it's just a string, right? All it would take is one more line for me to say the format is of type email, so that at least I can validate that it's an email. Now, the specificity of an API specification is extremely important from the point of view of various tooling around it. For example, code generation, right? If you're not specific about what is the data type, the number or the decimal, or in terms of the email for that matter, which we're showing here, the code generation tools and other tools which we deal with will not be able to make the most out of your API specification. So the design phase has to really account for all of these things to make sure that the developer experience, which is again just one of the aspects, is taken care of. Now we had to do all of this at speed, and that's where when we do a schema design, we don't want to waste that effort. The schema design, once done for your request response sort of a setup with your OpenAPI, you do that well and you put the effort into it. We don't want to deal with again having to reinvent the wheel when we go into event driven architecture or vice versa. You define the schema once, it's your standard domain library, and that domain library should be reusable across the board so that we can achieve speed. Otherwise, it's impossible for us to keep doing this over and over again and keeping all of these aspects in mind. And once you're done with the design phase, obviously you're going to launch, right? Now, let me ask you a question. How many of you here actually use a Postman collection or distribute a Postman collection? I think quite a bit of the companies that I know distribute Postman collection in addition to their API specification. And when asked why do you do it, it's mostly because people like to play around with the API specification. They like to get their hands dirty. So the Postman collection gives that experience of being able to, hey, can I fire this request and what happens when it comes back. The Postman collection also has example data in it, and you look at it and that's what it is. Again, I'm taking Postman as a example here, but you could use any collection tool like of your choice. But the reality of the matter is that the best we could do? Certainly not, right? We could do a lot better. What do we really want to achieve? First is a conformance verification. So if I'm the one building the API as a developer and the architect has already put an API specification together for me, what would I would love for me to have is for me to be able to get feedback when I'm deviating from what the designer set forth, right? So that's where a conformance verification is necessary to say, hey, here's how much you've done, here's how much is pending, and as you're deviating, you can say, here's the problems with your implementation itself. So conformance verification is number one. Now, obviously, you are being very nice to the provider developer here. What about the consumers, right? How do you help them get the most out of it? That's where a reference implementation or a sandbox is certainly important, right? They don't have to wait for the provider service to be built, or even better, get an access to a live environment or something that is hosted outside the control of the consumer. Consumers should have the ability to independently move forward. So in addition to API specification, they need the artifact, which is basically a sandbox or an API mock they can spin up locally or within their control and move forward. And also be sure that this mock is a true representation of what the actual service will behave like, right? So these two artifacts, in my humble opinion, and in our experience, where we have seen, is a lot more effective compared to just handing over collections. Because ideally what you want is not just a playground, you want a conformance check for the provider, and you want a proper truly representative sandbox or a reference implementation for the consumer, which is battle tested and ready to go. So with that, I'll quickly jump into a live demo of all of this what we've spoken about, and let's see how that looks. So What I have here is the schema reuse and section within my folders. And let me collapse this. The API specification I'm going to be showing you here is nothing new. It's the same that Naresh has already explained to you, that we have a bunch of operations, and for the schema itself, we are referring outside uh, instead of actually trying to put everything into this. So this is going into a common file here, and this is the common schema which is sitting here between the AsyncAPI and OpenAPI. So first, let's start with the OpenAPI side of things. Let's run a mock server from the OpenAPI, just basis the API specification, and see where that goes. Okay. So let me open up my README, and let me kick off my command here. It's a Specmatic virtualize and the API specification. And as you can see, it's just an executable. I ran it on my command line. It says it's running on port 9000. Right. So let's try out what this API specification looks like. So here, what I'm going to do is go to the API spec itself, and I'm going to say preview, and that launches the obviously the Swagger UI for this application. So I already have it pointing to localhost 9000, which is where my virtual service or virtualization is running. And I could go and say I want to try this out. Right. I can play around with it, and beautifully enough, my API specification has examples, right? We spoke about it. It's really, really important to have examples in your API specification from an educational standpoint. Because now for the user, I know that order ID 1 is an example which is already sitting here. I use this and then I say, try it out, and I'll say execute, and I got it. I got the response back from the server, and you will notice that the request came to the mock service for orders one, and the API basis the API specification, the response has also been served. So as a consumer developer, I already have mock service running, and this is fully in my control. This is in my machine. I don't have to wait for any other environment. I can plug away from the internet, if you will, and sit on a beach and develop my application. Right? Of course, not without my chat GPT, which is sitting here. Sure, but anyway, now that's the consumer side of things. So let me go back to how do we verify the second part of it. So this the mock is running, and let's say I want to, for the provider side, they need to run the test and verify that this is indeed correct. So what do I do there? Again, all I need to do is run Specmatic test order service sync, and that's pretty much my conformance verification, whether I'm adhering to the spec or not. Now, again, in this context here, instead of actually building the real application, I have a mock running. So I'll just run the test against the mock, just show you what the report looks like in terms of a conformance. So as I have run the test, I get a 50% coverage. Let's actually look at the more interactive version of this report itself. So I'll go here and launch it. So this is an API coverage report. It's not a code coverage report. The API coverage report clearly says there are 4 operations here for each of this 200 and 400. The 200 operations are covered basis the examples. I can click through. I can see that the data that is being used as the test data to send the information is again the basis examples and the API specification itself. I get back the response from the server, and the tests are passing. Now, obviously, because only 2 of them have run among 4 operations, you're getting a 50% API coverage. Now, this is a very good feedback cycle for the provider application because builder, because I have a conformance check every time I deviate from this. I'll have feedback, and it's almost like test driven development, right? I have tests to go with it even before I have built the application, and I don't have to put any effort into it. It's zero code. I just run the spec as a test, and the tests are generated for me on the fly. As the spec changes, the test will change. All right. So now that's enough with the synchronous part of it. Let's look at the more interesting piece, which is how do we run the same setup for a contract test and mocking for our asynchronous piece. So again, I have the asynchronous API specification. Again, the same file that Naresh had earlier called out. And as you can see, this file is also calling out or referring out to the same common order schema here. So if I locate it, it's right here. We're using the same thing. So I will go ahead and launch a virtualization. And here in this case, we're using Kafka. You could use anything like Google PubSub or a messaging middleware of your choice. Again, async API specification is agnostic to that particular technology. So I'm going to say Specmatic Kafka virtualize this particular API specification. And as you can rightly see here, the orders, new orders and the VIP orders, these are the topics or the channels that have been defined in the API specification, and the mock is already beginning to listen there. Again, you don't have to take my word for it. What I'll do is I'll start off an observability dashboard using CafDrop. So I'll kick that off in a separate screen here, and CafDrop is running in port 9000. So let me go ahead and go to 9000. And there you go. Calf drop is running. It is also reflecting the new orders. Obviously, the partitions are right here. The offsets are 0. There are no messages yet. I'll make that a little bigger so you can see. And we have a running mock. Just out of the API specification, I don't have anything much else to deal with here. Okay. Now, again, all of you know the next what is coming here, right? Conformance testing for the API specification. The rinse and repeat. I'm going to take Specmatic Kafka and say test for this particular async API specification and run it. And as I run it, you will see that a bunch of messages have been sent to the topic. Say, and here's the payload, and responses have been received on topics. Again, this particular API specification uses the request reply pattern, which is why you're seeing a request going out and a response coming back in. Here is the, let me just show you that. Here is the request reply pattern being put into use. Of course, you can have various patterns in async API. It could be a fire and forget. In that case, the behavior will be slightly different in terms of how the contract test is run. But here we've run, send the message, we've received the response, and we have verified it. So let me quickly show you the report for this also. So I have this report here. Let me launch it. And just like how I showed you for the coverage report for that, here I have messages being sent out and messages being received, and again being held accountable to the schema, which is the common schema between the OpenAPI and the async API specification. Again, we can verify the same looking at calf drop here, and you can see that this now if I go to new orders, the offset has changed and the message is right here in Kafka, and the broker is running in my local setup. So I'll stop with that because basically I just wanted to show you a sense of the fact that all I have is a common schema here. This common schema is being maintained across both synchronous and asynchronous systems in my event-driven architecture as well as my RESTful application using OpenAPI and AsyncAPI respectively. And none of this I had to do any effort. The whole experience for the developer for conformance testing and having a sandbox for reference implementation is all taken care of, right? And with that, let me quickly jump back into the slide and say, uh, like this is all we've seen right here, all the demos, and then comes to the evolution phase, right? Beyond the implementation, we have the evolution phase. Evolution is where we want to be worried about backward compatibility testing and versioning. We have to be concerned about that. Again, this is a natural evolution of what we've already seen. If you're able to run a spec as a test and run the other spec, a spec also as a stub. So obviously you can run the newer version as a mock server and the older version as a test against it to verify backward compatibility using Specmatic, right? And that's something that we discovered or chanced upon, and big has become a very important capability for us. And once you know whether there's a breaking change or not, you can decide on your versioning strategy for that. Again, in the interest of time, I'll stop going into the depth of evaluation stage. I'll move forward and recap. You the design phase, you standardize, you do not repeat yourself, you provide sufficient examples for educational purposes, and you're both consistent and specific, and doing all this at speed. We can do that with at speed because obviously we are reusing the schema across both sites, and ultimately during implementation we want the capability to be able to provide use feedback to users, providers, by way of conformance verification, and for consumers by way of sandbox capability, and evolve using backward compatibility checking and then versioning. And everything is driven by API specifications, OpenAPI, AsyncAPI, and a common JSON shared JSON schema. is that's the whole quick recap of it. What's the journey ahead? So far we've seen schema reuse across OpenAPI and AsyncAPI. And when we get into composing independent operations into Arazo, which is the API specification for workflows, we also see a lot more reuse coming into picture. But that's very, very soon. But in the interest of time, I'd like you to leave that curiosity with you in terms of what all is possible. And we've shown you the art of possible right now, and we hope to hear back in terms of what you think and where else we could do reuse and reduce the amount of repetition. So with that, I will again thank you. Over to you, Naresh. Also, if you want to make any closing statements.
No, I think that was great. Thanks, Hari, for doing a quick recap. And I think, yeah, we probably are out of time. So we'll leave that for now. And thanks again, everyone, for watching this video. Look forward to hearing from you, your thoughts and experiences.
Thank you. Bye bye.